Hello children, consider this equation 2x minus 2y is equal to 0. Just pause this video for a moment and find values of x and y which would satisfy this equation. Can you do it? Yeah. You would be able to do it easily. Some of you would have found 1 and 1 and some of you would have found 2 and 2 and many of you would have noticed that any value of x and y which are equal satisfies this equation. So even a -5 and a -5 would satisfy this equation. So if you plot this geometrically, you are going to plot these points geometrically, all the x coordinates, all your x values in the x axis and plotting all the y values in the y axis, what would you get? You would get an equation, a line which represents 2x minus 2y, which passes through the origin 0 comma 0, because 0 and 0 is also a value which satisfies, isn't it? 0 and 0 is also satisfies 2x minus 2y is equal to 0. So if you notice that every point in this line represents 2x minus 2y is equal to 0. Every point in this line is a solution to this equation. So you have infinite solutions, right? So suppose this equation represents x represents the temperature of the fridge and y represents the temperature of the freezer. X is fridge temperature, right? And y is the freezer temperature. You are given a sum, a problem to be solved, and you are given that twice the freezer temperature minus twice the fridge temperature is equal to 0, and you're asked to solve for it. You're asked to find those temperatures of the fridge and the freezer which satisfy the equation. So you would be getting infinite number of fridge and freezer temperatures which satisfy. So you would ultimately there would be no solution to this equation. So what do you need in order to solve this? You need more information, right? So let's assume that you are given one more information. The sum of the freezer and the fridge temperatures is equal to 0. Suppose you are given this. So now if you draw a graph geometrically, first let us do it geometrically. Of course we can do it algebraically also, but let us try to visualize it first. So what is y? If you change the x to the other side of the equation, you get y is equal to negative of x. So this time if you represent this geometrically, you would be getting a line like this. Your y is equal to minus x or x plus y is equal to 0 can be represented by this line, isn't it? If you check every point in this line, I'll do the checking for you. Suppose take this particular point. This is x is 1 and y is minus 1, right? It represents y is equal to negative of x. So if you take a point here, this side, say this is 2, x is 2, x is minus 2. X is minus 2, your y is 2. So again, it satisfies y is equal to minus x. So now can you find the fridge and the freezer temperatures? Yes, it is this point where both the lines intersect. Both the lines representing these two equations. This is your equation 1 and this is your equation 2. So both these lines intersect at a particular point and that is the solution. So the solution of these two equations is 0 comma 0, which means that your fridge temperature is 0 and your freezer temperature is also 0. So you need two equations. If you have a linear equation in two variables, this is a linear equation, right? Because we draw a line using this equation. Linear equation in two variables. In order to solve the linear equation in two variables, you need a pair. You need a pair of linear equations. But the question now is it always possible to solve if you have a pair of linear equations? Is it always possible to find a unique point, a unique solution? Let's explore that also. Suppose your second information was not this. This was not given to you. Instead, you were told that 4 into the temperature of the fridge minus 4 into the temperature of the freezer is equal to 0. So what would you do? How would your graph look now? So this, if you divide this equation by 2 throughout, you divide it by 2 throughout, you get the same 2x minus 2y is equal to 0, right? See, so this information is redundant. It's of no use to you. If you plot the points and if you represent it graphically, you will again get the same graph. For this also represents 4x minus 4y is equal to 0. So once again, you have infinite solutions. So this are represent the one and the same equation, so there is no possibility for a unique solution. And any other case where you cannot find a unique solution? Yeah, here we saw that the lines are one over the other, they're coincident, they're one over the other. What if the lines are parallel? What if you get an information which represents some line which is parallel to 2x minus 2y is equal to 0? Consider this equation. Say it's 2x minus 2y is equal to 5. So you will get a parallel line. Again, these lines will never meet. So you will not get a solution. Of course, we will see these cases formally later on. This video is just an introduction to pair of linear equations and two variables. Why we need a pair in order to solve equations and two variables. We will have all these special cases later on in our later videos. We will see when the lines are parallel, when the lines are coincident, etc. I hope you understood, and I hope you understood the motto of this video. Thank you.